A big greeting to Dr. Rosita binti Ahmad. We are Group 2, and today we would like to present our project, Software Engineering Framework for the Touch and Go eWallet System. My name is Tew Rou Ling, and my group members are Wei Jun, Qin Wei, Caitlyn, Qian, and Cheong Jian. Touch and Go eWallet is a digital payment platform developed in Malaysia. It is a mobile-based fintech application that allows users to perform cashless transactions using their smartphone. The application provides various services such as QR code payments, money transfer, bill payments, wallet reloads, and financial service management. This feature allows users to manage their daily financial activities conveniently within a single application. The main purpose of Touch and Go eWallet is to provide a fast, secure, and convenient alternative to traditional cash transactions. Users can make payments, transfer money, and access financial service anytime and anywhere without carrying physical cash. Due to its convenience and wide acceptance among merchants in Malaysia, Touch and Go eWallet has become one of the most popular digital wallet applications in the country. Touch and Go eWallet is important because it supports the growth of digital payment in Malaysia and encourages the adoption of a cashless society. Compared to traditional cash payment, it reduces the need to carry physical cash and allows users to complete transactions more quickly and efficiently. It can also be used for both online and physical purchases, making it suitable for daily activities. Some key benefits of the system include convenience, contactless QR payments, and real-time transaction processing. In addition, users can easily track their spending and transaction records through the application. The system also provides enhanced security through features such as PIN verification, OTP verification, and biometric authentication, which help protect user accounts and financial information. The purpose of this project is to analyze the Touch and Go e-wallet system from a software engineering perspective and understand how a digital wallet application is designed and developed. The main objectives are to identify the system functional requirements and non-functional requirements, select a suitable software process model, develop software test cases, and prepare project planning and risk management activities. Through this analysis, we can gain a better understanding of software development practice in real-world fintech application and learn how software engineering concepts are applied to a digital payment system. The knowledge gained from this project helps us to understand the importance of proper system analysis, planning, testing, and management in developing a successful software system.
For this project, our group selected the Agile software process model. Agile is an iterative and incremental approach where the system is developed in short sprints with continuous testing and feedback. It is suitable for Touch and Go eWallet because the application requires regular feature enhancements, security updates, and quick adaptation to changing user requirements. Thus, Agile helps improve software quality while reducing development risks. Touch and Go eWallet is considered a moderately complex fintech application because it consists of multiple interconnected modules such as QR payment, money transfer, wallet reload, and transaction history. In addition, the system requires strong security features including OTP verification, PIN authentication, and biometric authentication to protect users and financial data. Furthermore, the application must provide fast transaction processing, maintain high availability with a target uptime of 99.95%, and support future growth as the number of users and services increases. Therefore, the Agile model is suitable because it supports continuous testing, incremental development, and flexibility to adapt to changing requirements.
Our project team consists of 5 members and each member is assigned a specific responsibility. The system analyst is responsible for gathering and analyzing requirements. The system design the user interface, database, and system architecture. The developers implement the system functionalities such as registrations, QR payments, money transfer, and wallet reload. The software tester performs testing to ensure the system functions correctly, while the deployment engineer handles deployments and project documentation. The Agile model is suitable because it encourages collaborations, continuous communications, and regular feedback among team members.
Hi, I'm Caitlyn. I'll be covering 3 parts of our report: requirement stability, the design stage, and the implementation stage of the Touch and Go eWallet. Requirement stability refers to how likely a requirement is to change during the development lifecycle, and it directly affects which process model fits best. For our TNG eWallet, the stability is moderately high. The core operation, registration, payments, transfer are well defined from the start and unlikely to change, but some features and quality requirements will evolve over time based on user feedback, new technology, and Bank Negara Malaysia regulations. That mix of stable and evolving requirements is exactly why Agile suits this project. We group the requirement into 3 levels. The stable ones are the core functions an eWallet can operate without: registration, QR payments, transfers, reloads, and transaction history. These are delivered in the earliest sprint to build a solid foundation. The semi-stable ones, like performance and usability, are defined early but get refined. For example, our 3-second login target might be adjusted after load testing. And the flexible ones, like advanced security, high availability, and future services, such as investments and insurance are expected to change as threats evolve and the business grows. Agile handles all three in the same life cycle.
Let us continue with development stages. The first development stage is requirement gathering. At this stage, the goal is to identify the features and quality requirements needed by users of the Touch 'n Go eWallet system. The requirements were gathered through three methods: researching on the official Touch 'n Go eWallet website, observing the existing application, and analyzing user needs and expectations regarding the digital payment system. Based on this analysis, both functional and non-functional requirements were identified. Functional requirements describe the functions and services that the system must provide to users. Five main functional requirements were identified. FR01 is user registration and login, which allows users to create and access their account. FR02 is QR code payment, which enables users to make cashless payment by scanning QR codes. FR03 is money transfer, which allows users to transfer funds to other Touch 'n Go eWallet users. FR04 is wallet reload, which enable users to add funds to their eWallet balance. And finally, FR05 is transaction history, which allow users to view and track their previous transactions. Non-functional requirements describe the quality attributes of the system and how well it performs. Five non-functional requirements were identified. FR06 is security, which ensures user data and transactions are protected. FR07 is performance, which focuses on fast response times and efficient transaction processing. FR08 is availability, which ensures the system remains accessible with minimal downtime. FR09 is usability, which provides a simple and user-friendly interface. Lastly, FR10 is scalability, which enables the system to support increasing number of users and transactions in the future. These functional and non-functional requirements serve as the foundation for the next stages of system design, implementation, and deployment.
The design stage turns the requirements we gathered into a detailed technical blueprint that guides the developers. Our design focuses on three areas: the user interface, the database, and the security architecture. Let me take each one. For the user interface, our main goal was usability, making sure users reach important functions within three tabs with clear icons and labels. We followed a progressive disclosure approach, meaning the most frequent actions are shown up front on the home screen, while detailed function sits in their own subscreen. As you can see on the home screen here, the quick access row, scan, pay, transfer, and TNG card is right at the top, so the main actions are reachable and in just a couple taps. Beyond the home screen, every main function has its own dedicated screen, all following a consistent layout. Here you can see the login screen with passkey and biometric options, the QR payment flow with the verification step, the wallet reload walkthrough, and the transaction history with its category and date filters. Each one maps directly to a functional requirement FR01 to FR05. For the database, we use a relational model to keep the data consistent and reliable, essential for any financial system. It's built on four core entities. The user table stores account and login details. Each user links to a wallet that holds their balance. Every payment or transfer creates a record in the transaction table, and the QR payment table manages QR codes and links back to the transaction once a payment is completed. These tables connect through primary and foreign keys, so every transaction can be traced accurately. Security was treated as a layer built into every part of the system, not a single add-on, and this is required by the Personal Data Protection Act and Bank Negara Malaysia. There are four layers. First, OTP verification during registration and PIN reset, expiring after 5 minutes. Second, a 6-digit PIN or biometric verification for every transaction. And any QR payment above 250 ringgit Malaysia forces extra verification. Third, account logout after repeated failed attempts and auto logout after 5 minutes of inactivity. And fourth, all passwords and pins are stored as sorted SHA-256 hashes with TLS 1.3 encrypting data in transit. No plain credential and ever stopped. In implementation stage, the design is turned into working software, built incrementally across 4 sprints. Each sprint runs 2 to 3 weeks of development followed by a 1-week review. So we always delivered a testable working feature set before moving. We subsequent the sprints by dependency. Sprint 1 builds registration and login, the security foundation everything else relies on. Sprint 2 adds wallet reload because users need funds before they can pay or transfer. Sprint 3 is the most complex. Money transfer and QR payment are developed together. Since both modify wallet balances, so we use atomic transaction logic to make sure a balance is never half updated. Finally, Sprint 4 delivers transaction history and spending analytics, and because every earlier module fits into it, this also becomes our system testing and user acceptance testing sprint. After each sprint, we ran the 3 Scrum activities: a sprint review to demonstrate the features and collect feedback, a retrospective to discuss what could improve, and a backlog refinement to prioritize any requirements for the next sprint. For a security-sensitive financial app, this continuous feedback loop is what makes sure each layer is solid before the next is built on top, and that's wrap up the design and implementation.
Our testing strategy ensures that eWallet is secure, functional, and user-friendly. We begin with unit testing, using white box isolation to validate the OTP engine 5-minute expiration and SHA-256 hashing for security. Now, integration testing then confirms that the wallet reloads and updates the database instantly, ensuring bank authorization tokens pass to gateways without timing errors. Now, for system testing, we use black box workflows to stress test performance, ensuring QR payments process within a 5-second threshold and the server recovers from failure within 2 minutes. Finally, user acceptance testing, the UAT, evaluates usability, confirming that users can reach the pay function within 3 taps and that PIN authentication is strictly triggered at the Ringgit Malaysia 250 and 1 cent boundary. Now, moving to deployment, our system relies on geographically distributed cloud servers to maintain continuity during regional outages. To handle high-traffic events like major e-commerce sales, such as 11/11, we utilize dynamic horizontal scaling, which injects resources without requiring a system redesign. Now, system monitoring is central to our operations in Touch 'n Go eWallet, targeting a strict 99.95% availability uptime with automated alerts. Now, we also track transactions per second to intervene before delays trigger user cancellations. For long-term evolution, we maintain an agile product backlog to integrate BNM compliance updates and perform continuous regression testing to protect existing code from new bugs.
The functional requirement selected for testing is the QR code payment feature. This feature allows users to scan static and dynamic QR codes to make payments, verify merchant information before payment, generate personal QR codes to receive money, and view transaction records. We selected this requirement because it is one of the core features of Touch 'n Go e-wallets and involves financial transactions that require high accuracy and security. For QR code payment, a total of 14 test cases were developed and grouped into 4 categories. First, normal scenarios are tested, including static QR payment, dynamic QR payment, and merchant verification before payment. These test cases covered all major QR payment functions, validate common user activities, and ensure the QR payment feature operates correctly during normal usage. Second, error handling is tested through invalid, expired, and unreadable QR codes to ensure the system displays appropriate error messages, detects invalid inputs correctly, and prevents incorrect and unauthorized transactions. Third, boundary value analysis is applied at RM 249.99, RM 250, and RM 250.01 to verify that additional authentication is only required when the payment amount exceeds 250 ringgit. This ensures that the authentication rule is implemented correctly at the boundary values. Finally, other functionalities such as transaction history, balance updates, direct scan access, and personal QR generation are also tested to ensure supporting features work correctly. In addition, transaction security is verified through high-value payment scenarios with incorrect PIN authentication, while the accuracy of financial information such as receipts, wallet balance, and transaction history is also validated. Overall, these test cases are suitable because they cover all QR payment functionalities, validate normal user behavior, test invalid condition, verify authentication boundaries, ensure transaction security, and maintain the accuracy of financial information. Since black box testing is used, the system is evaluated from the user's perspective. Therefore, all 14 test cases passed successfully, indicating that the QR code payment feature fulfills all specified functional requirements.
For software testing, we selected money transfer feature. This feature allows user to transfer money directly to another registered Touch 'n Go eWallet user using a phone number or contact list. Before a transfer is completed, the system verifies that the recipient assists and checks whether the sender has sufficient wallet balance. The user must also authenticate the transaction using a PIN or biometric verifications. After a successful transfer, the sender's balance is deducted and the recipient balance is updated. Notifications are sent to both user and the transaction is recorded in the transaction history. Because this feature involves financial transactions, it is important to ensure that it operates accurately and securely. We developed several test cases using black box testing and boundary value analysis. Black box testing is used to verify normal and error scenarios such as successful transfer, invalid recipient, insufficient balance, incorrect PINs, and network interruption. Boundary value analysis is used to test transfer amount around the wallet balance limit, such as 99.99 ringgit, 100 ringgit, and 100.01 ringgit. These test cases help ensure that the money transfer features function correctly under different conditions. These test cases are suitable because they cover all major functions of the money transfer feature. They verify normal users' activities, test invalid condition, and check boundary values where errors commonly occur. The test cases also ensure transaction security through PIN verifications and confirm that wallet balances and transaction records are updated correctly. Therefore, the selected test cases provide comprehensive validation of the money transfer functionality.
This slide shows the project planning timeline for the development of the Touch and Go eWallet system, which is scheduled over a period of 4 months from May to August. In May, the team focused on requirement gathering to identify the system requirements and user needs. At the same time, the system design phase begins and continues into June. During May and June, activities such as user interface design, database design, and system architecture design are completed. The implementation phase takes place from June to July, where the main functionalities such as user registration, QR code payment, money transfer, wallet reload, and transaction history are developed. Testing is conducted in July to verify that all functions operate correctly and meet user requirements. Finally, in August, the system is developed and product documentation, final report, and presentation materials are completed. This timeline helps ensure that the project progresses systematically and that all development activities are complete within the planned 4-month schedule. This slide presents the major milestone of the project and their target completion dates. The first milestone is requirements approved, which is scheduled for 31st May 2026. At this stage, all functional and non-functional requirements have been identified and approved. The second milestone is design complete, target for 30 June 2026, where the users interface, database, and system architecture designs are finalized. The third milestone is core functions developed, scheduled for 31st July 2026. By this stage, key features such as user registration, QR payments, money transfer, wallet reload, and transaction history have been implemented. The fourth milestone is testing complete, also target for 31st July 2026, after all testing activities have been carried out and identified issues have been resolved. Finally, the last milestone is final deployment, scheduled for 31st August 2026, where the system is deployed and all project documentation is complete. This milestone helps track project progress and ensure that each development phase is complete according to schedule.
Our risk management strategy targets 3 main categories. To mitigate project risk, such as staff turnover, we use pair programming and a 30% schedule contingency buffer to prevent islands of expertise. Now, for product risk, specifically shifting BNM regulations, we utilize short 2 to 4 week agile sprints to adapt features quickly without structural decay. And finally, business risk, like data breaches or peak load crashes, are countered with TLS 1.3 encryption, salted hashing, and horizontal scalability. These measures ensure our system remains in strict compliance with the Personal Data Protection Act 2010 and BNM mandates, protecting user trust at all times.
In conclusion, Touch and Go eWallet is a secure and convenient digital payment platform that supports a wide range of cashless transactions, including user registration, QR code payments, money transfer, wallet reloads, and transaction history tracking. The system is supported by important qualities such as security, performance, availability, usability, and scalability, which ensure a reliable and user-friendly experience for its users. In addition, Touch and Go eWallet plays an important role in promoting cashless transactions and supporting Malaysia's digital economy by improving convenience, efficiency, and accessibility in financial services. Overall, the system demonstrates how software engineering principles can be applied to develop a successful fintech application that meets both user and business requirements. Thank you for your attention, and that's all from our group.